Hi, my name is Alexina. I'm a postdoc here at QNS, and I am working in the building team. So now we are making a STM named Dave. So Dave is a optic STM. So we want to combine optics and scanning probe together to have atomic resolution and optical property of the sample that we want to measure. So the specialty is the optic part. So we have here all this big structure. It's to bring light into our system using a fiber. And this is the first time we do this here in QNS. The most important thing is the light and how we bring light into the junction, because most of the people using free space, so they just shine the laser and try to bring this light into the junction, while we are using a fiber, and it's the most tricky part of it. The most interesting thing is the building, because this project is not like the others. We are not measuring samples because we are making all of this. So for me, it's all the process of building, understanding every part that we are putting in and how they can affect what we see. And first, we want to see if it works. So we want to induce light. It's called electroluminescence. So we apply a tunneling current and try to see the light coming out of the junction. I hope almost finished. Now we want to test at low temperature to see if everything works and if we can do what we want to do and adjust what needs to be adjusted, and hopefully in a few months it will be over. So like I said, we are using a fiber to bring the light in the junction. And as you can see, this fiber is very small and very fragile. So this one was our 10th try. So we are making a list and count who is breaking the most the fiber. And so far, one journal is winning. Yeah, when you buy a commercial machine and when you make it yourself, you can understand the different challenges and why sometimes the companies are making weird decisions, because we have to make them sometimes, and we can understand also how everything works. And I think this is the most interesting part.